Great. This is going to be good enough. All right, so I'm going to skip that. Total market has reached $28.6 billion in 2015. That's moderate growth from 2014. I'll skip ahead a little bit. An important part of this forecast that we talked about in our last presentation at HPCAC is that we've taken what we now call the hyperscale market out of the HPC market. This is something we started tracking in 2007 as what we then called ultra-scale internet. This is the idea that companies like Google or Facebook or Amazon are acquiring HPC technologies for the purpose of what you could call arbitrarily scalable web-facing application infrastructures, right? But it's a little different from HPC. And as of the end of last year, we realized that hyperscale had grown and evolved to the point where it was really a separate market that is a proximity market to HPC, but distinct from HPC. And it's not just those top-tier customers where we do count 10 companies at the top who spend over $1 billion a year, billion with a B, $1 billion a year on IT at the top. There are 3 of them that spend more than $2 billion a year. There's one that spent more than $3 billion in 2015, and we haven't named who they are, but that'll be left as an exercise to the readers. Beyond that, there's a whole second and third tier of hyperscale markets of, it doesn't have to be someone in the top tier. Organizations like Wikipedia and PayPal or a lot of telecoms have these scalable application infrastructures that count as hyperscale that are not going to be counted as part of HPC going forward. We've also taken gaming. Online games used to be an HPC segment of ours that's really more like hyperscale than it is like HPC, so we've moved it over to the market, and all of these numbers are retrofitted. Looking at 2015 versus 2014, cloud did post a double-digit growth rate, but that's coming from a very small base in HPC. Cloud is still only about 2.5% of the overall spending in HPC. Now, when we're talking about cloud from this perspective, what we're talking about is someone is paying to run their HPC application on an external cloud infrastructure. So if I'm running a CFD application on Amazon EC2, for example, what I pay to them goes into this. What Amazon pays to buy the servers that then go into Amazon EC2 is not part of that number. That's part of the hyperscale market, if that's clear. Servers are still the largest component. Overall, the market growing 2.7%. All of the hardware categories are growing. Software actually declined a little bit. Software has been softening here, mostly due to an industry-wide trend away from purchased licensed ISV software to a heavier integration of open source and also more in-house developed software, largely as a reaction to the challenge in licensing models around multi-core and many-core, which isn't to slap the ISVs and say you're charging too much. The fact of the matter is you made scalability harder. You've introduced all these heterogeneous components. You've gotten a multi-core, and no one wants to pay you anything more for that software scalability. So the business model for ISVs right now is really quite challenging. When we put together the forecast, we look at a lot at our end user budget map information. We do 2 surveys every year, our site census survey on what people have installed and our budget map survey on how money gets spent in and between different categories, and part of that is what people's budget outlook is going forward. You can see that the industrial sector, the commercial markets, are really continuing as the driver for most of the growth in high-performance computing. We still see industry and academia being soft. This is bolstered by our survey responses here. It's not negative, but it remains quite low. A lot of the growth in this market market is really going to continue to be driven by the industrial markets. The government markets, it's just hard to find a government sector that's good right now. The U.S. is still under sequester. The Eurozone has its own crises. You've got problems in Japan, problems in China. There just is not a really strong government spending sector right now, and then that affects academia as well. A big thing going on in the vendor share all had to do with the sale of the x86 systems from IBM over to Lenovo. Now this closed after the end of the third calendar quarter of 2014. So in 2015, you should see all new vendor shares. There was maybe one quarter at the end of 2014 where stuff started to move over to Lenovo, and then 2015 should be a full Lenovo year for all of that business. So the blue lines here are shares. There are some figments still left in our databases like Sun we've been tracking for a long time. They're kind of still in there. To the extent that we're talking about them at all, it should be Oracle, but really it should be part of others, so forget that. SGI will next become part of HP. The blue bars are the ones that should be blue if the projector were good here, are the current shares for 2015. You see HP is the market leader with a narrow lead over Dell on the system side. That will expand as they bring in SGI. HP also has a little more recent growth over Dell, a little more momentum. What should be a red bar, this dark bar, is the change in share from 2014 to 2015. So you see the decline from IBM, and then it goes up everywhere else. Now what you see is that Lenovo didn't do a very good job holding on to all of this share, that HP got about almost as much of a bump as Lenovo did, stealing a lot of that share, but really everybody went up. Cray went up, Dell went up, SGI went up. All of that is grabbing share away from IBM and that x86 transition from Lenovo. Lenovo didn't hold on to as much of it as it should have. But the other interesting thing here that I'm going to take a minute to point out is that IBM really didn't lose as much as it should have. Going into this, about 2/3 of IBM's HPC business was x86 based. So really you'd expect to see 2/3 of their business drop off, and they didn't replace all of that with power. That didn't happen. We know that from our surveys. And that didn't fall as much as all that. And believe me when I tell you, we looked at every quarterly number, every annual number for IBM and Lenovo. We spent a lot of time on those sheets trying to dig at that, and also on our surveys from end users to see what's going on. And we came to the inescapable conclusion that no matter how complete that deal was supposed to have been in 2014, that IBM still held on to a certain amount of x86-based server revenue in HPC in 2015. Now, IBM will tell us that's not true, but we could think of any number of reasons why it might have been true anyway, particularly early in the year. The likeliest culprits would be delayed revenue recognition on large deals. They sold something before it closed, but then it took 3 months, 6 months to pass acceptance, and then they recognize the revenue. Other possible contributors are inventory in the channel. You know, the channel was holding an IBM server, sold it later, then the money goes back to IBM. Unexpired leasing revenue. Someone started a long lease, and then IBM is recognizing that revenue a little bit at a time instead of all at once. Then there's also the possibility of special arrangements with special clients that IBM's not telling us about. But at any rate, our analyst viewpoint on that is that IBM still had a fair bit of x86 revenue in there in 2015, and we'll see that continue to evolve in the 2016 numbers. Going to the forecast, a couple funny things my partner likes to say. One is that when you make a forecast, it has to be bound by what's realistic, but reality has no such restriction. Reality can do whatever it wants. So that's why forecasts tend to be smooth, but then reality tends to get choppy because weird things happen. The other thing that's not original to Chris, but he nevertheless likes to say it, is the time is nature's way of keeping everything from happening at once. That has a corollary. Space is nature's way of keeping it all from happening to me. But it's relevant to the forecast because when you try to project things that are discontinuous, they don't happen all at once. Things like cloud and object storage and InfiniBand, when it first came in, take time to come into the market. It doesn't all happen in 1 year. Looking at the forecast, we do see continued growth in HPC. Now, this is coming out of a couple of really flat years, 2012 through 2014. Everything here up through 2015, now you can see, is our actuals, and then we're forecasting 2016 through 2020. A lot of the growth here is driven, as I said, by commercial markets. Take a look at a few things. One is, after servers, the next two biggest areas are storage and software. Storage has one of the higher growth rates, but software has one of the lower ones. And that's due to some of the dynamics I already pointed out. And then second from the top, that smallest bar there is cloud, where we're talking about how much money people are spending to run their HPC applications on cloud resources. You do see it has kind of an elbow year there in 2014 where it starts growing faster, but by the end of this forecast period, it still doesn't get above 5% of the market. It's probably going to be in the 3-4% range of the market. It's growing quickly, but from such a small base, it just doesn't rate. This is the same picture from just from a percentage basis, if you level everything out at 100% and look at how they all change. So you can see that cloud, at some point, it has to be a zero-sum game that comes from other areas. All right, what I really want to get to is not just this forecast, but on this 10-year theme, looking back 10 years and trying to look ahead 10 years. This is where it really gets fun as an analyst to try to think of where things are. Where we were in 2006. Does anyone remember 2006? I mean, it's kind of so long ago. It was kind of crazy. This is hard to read, I'm sorry, but Intel, first of all, was not the #1 processor vendor in HPC in the year 2006. It was AMD. Opteron outshipped Intel into the HPC market that calendar year, pretty much only that calendar year. Intel soon reclaimed it. AMD fumbled the Barcelona launch. Intel eventually got things going again. That was the last year that Intel wasn't the #1 processor vendor in HPC, but it did happen that year. The #1 on the top 500 list was an IBM Blue Gene L at Lawrence Livermore National Labs. It had been upgraded that year to 136 teraflops. It first made the list as a 70 teraflop machine in 2004, but in 2006 they doubled it. It stayed as the #1 machine on the list for 6 or 7 straight lists. This was kind of the middle of its run. Grid computing had been all the rage in the mid-2000s, but by 2006, all of the OGF meetings were still going on, and I found some of my presentations from them. The enthusiasm around grid was starting to wane, but we weren't yet talking about cloud. InfiniBand surpassed Miranet and other proprietary high-end interconnects in HPC. It wasn't yet up to where it is around half of the market now, but it was starting to eat away at those other high-end interconnects in 2006, so this was kind of a transitional year there. Parallel file systems existed, but they were still uncommon. You know, Lustre existed, GPFS existed, there were others that were out there, but their deployments were pretty rare. Most importantly, this was really around the start of the multi-core processor era. There were a few dual-core processors out there, and this is where things really started to change. Now, looking at that as the start of some really new things happening in the industry, I did a really scary thing, and I went back and looked at what were some of the things we published at the beginning of 2007 when we started as Tabor Research. I thought, what did we predict there? And for your enjoyment, I've actually pulled out those predictions and put them on the chart so we can look at how we did. 5 important predictions for HPC in 2007. I wrote in January 2007 as Tabor Research, and these were the things that we talked about. The very first prediction we made as Tabor Research analysts was that HPC would be described more in productivity and less in performance or flops. That did not happen, not in the last 10 years. Now, there is maybe hope for the future. We started talking about exascale, not exaflops. I'm still dubious that that's going to change, because I think most of the time when people talk about exascale, they're really thinking about exaflops. Unless someone's going to put up an exaflop computer and we as an industry are going to point to it and say that might be exaflops but it's not exascale, and talk about what the difference is, then we haven't really done this. So right there, right out of the chute, number one prediction we ever made as Tabor Research, I would say no, that's not happened. Second was that data is becoming more important and leading parallel file systems are going to begin to emerge. Got that one. Microsoft is going to grow its presence in HPC, buoyed by multi-core trends. That was true, believe it or not, for the next 2 years. Microsoft got to where it was over 20% of entry-level and mid-range systems in HPC, of new entry-level and mid-range systems in HPC. But then in 2009, Microsoft had a change in strategy. They moved all of HPC underneath cloud and had an very Azure-forward strategy. They also struggled with the larger systems, predominantly because of data management and I/O. They didn't have a good file system solution for how data moved in and out of a Windows cluster. They couldn't get CIFS to scale. PNFS on Windows never really took off. So that almost got going, but then became false. Power consumption will become a top-tier purchase consideration. That did happen. HPC growth will be driven by business applications, finance, gaming, logistics. Those have been the highest growth sectors over that time. We see, we're actually unique in the HPC analyst space in seeing finance for the size that it is in HPC. It's one of the dominant commercial application vertical markets. We made a few other predictions related to multi-core, that application performance will not keep up with multi-core architecture peaks. This was exactly what Martin was just talking about before I got up here. In fact, he described this in this article, Anticipating the Fall, a cartoon physics look at multi-core processing, in a 2008 blog where he talked about Wile E. Coyote has run off the cliff, but he doesn't fall yet because he hasn't looked down. And that's what we saw exactly happening then with multi-core processors, was that we were chasing theoretical performance off of a cliff, but we hadn't looked down yet to see what the problem was with the utilization of those, and that we were compensating by adding a lot more memory in as multi-core really took off. That memory per core stayed constant, and the more cores you put into the system, the more memory you needed. That stayed true for the entire last 8 years up until that point. It keeps happening, and application performance is suffering as a result. We also talked about the increased focus on middleware and developer tools, and said that acquisitions were likely in that space. That was good. Talked about the emergence of GPUs, said that was coming. That happened. So we're good. The more recent and complicated predictions, big data not a distinct enterprise market. That's correct, by the way. This is a difficult one. Big data is not a separate market. When someone says the size of the big data market is umpty-ump $1 billion and growing at whatever percent, ask somebody what they're counting. Right? Like, how many big datas is that? And how much does each one cost? Big data is not like HPC or hyperscale in having a separate, dedicated set of infrastructure for it. Big data gets mixed in with all of the rest of your enterprise market. And if you don't believe it, for all the big data spending going on, how much has the overall enterprise market changed? It stayed pretty flat. Big data is largely a reallocation of all this other stuff. Hadoop is not a killer app that's driving a whole lot of spending. We did predict that it would be a huge, substantial opportunity for the expanding use of HPC. That has not happened so far either. So that part we got wrong. We have not seen big data so far be a big driver of the increase of HPC-related technologies. Public cloud computing, a small portion of HPC market, will remain that way for the forecastable future. We got that right too, and that's to our own detriment. I'll tell you now as a professional analyst, no one likes to pay for small numbers. When you go out and tell someone that this isn't going to be a big opportunity, no one wants to pay you for that. People would have paid us a fortune to say that HPC in the cloud was going to be huge. We could have then been wrong, and no one would have come back and said, hey, you're wrong. It's a lot more profitable to just put a big number out there and then be wrong later. This one we got right, and that was not the right business model for us as a company. We got to sell our integrity. Intel will continue to make acquisitions and investments. IBM's going to defect from that. Intel will become a prime vendor for major supercomputing deals in the run-up to exascale. Yes, 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 all that is happening. So, overall, I think we're doing all right on some of these bigger predictions as analysts, and the surveys that we get back from the HPC community really help fuel those going forward. So the last thing I'll do before it hits 5 o'clock is try to make some bolder predictions for the next 10 years in HPC. Now, we only ever forecast 5, and I'm not going to get into the success or failure of any individual company or technology, but here's some big things that we think are happening. First of all, the fundamental drivers of HPC are going to remain strong forever. Until you wake up one day and you see you've reached the end of science, you've answered all the questions that there are, there's going to be more need for HPC, and there are more grand challenge problems out there that we're going to look forward to chasing. The one that I'm most looking forward to is some of the brain research going on. Think about the year 2000 and when we mapped the human genome. That sounds like the end of a problem. In reality, it's the beginning of the field of genomics, right? And it just takes off. Think about what's going to happen when one of these large-scale supercomputing projects builds a comprehensive map of the human brain. That's coming at some point, maybe in the next decade. That's kind of out there. Maybe 10 years is a good guess. Supercomputing is going to keep going. Specialization is going to proliferate again. We're at the end of what we've passed the end of what you could in hindsight call the Beowulf era, where systems were portable, or codes were portable, and once you were an MPI, everything was the same. We're going to go back to an era of specialization where you dedicate to a particular architecture, and that's going to create room in the market for custom architectures again. I think you will see custom novelty architecture starting to gain traction in the market again. Things are going to get more interesting. Public cloud or utility computing is going to remain well below 10% of the HPC market. 5 or 6% would be a good guess for the end of the 10-year period. Object storage is going to take off in commercial markets. I'm kind of skipping over parallel file systems for commercial markets. Parallel file systems like Lustre and GPFS still never really got going in commercial markets other than oil and gas. And I'm starting to think that in this 10-year time frame, you might increasingly see people skip over parallel file system and go to a no-FS implementation of object. That could start to happen. It'll be slow, but in the 10-year time frame, that could really happen. And then the biggest deal is the hyperscale market is going to have a tremendous effect here. Consuming HPC-associated technologies like high-performance processing elements or InfiniBand, especially in areas like deep learning. They have an enormous influence in defining system configurations, product specifications with things like Open Compute Project or Scorpio in China, OpenStack in software. These really drive a lot of industry development that's going to spill over back into HPC. And then finally, the revolutionary application areas that are really going to take off are going to be in the areas of AI and augmented reality, particularly in AI. Now, this is inclusive of machine learning, deep learning, but understand that this is predominantly a hyperscale application, well, technique, more than it is an HPC one. Of course, you can do HPC things with them, but most of this is going to get run in the cloud. Now, I just got done saying that cloud and HPC weren't going much together, but AI and cloud definitely are. The big Organizations that are pushing most of the research here are cloud service providers, and when one of them designs a widget to do healthcare analysis in the cloud, the training of that's going to be done in their cloud, and the inference apps that you give to doctors are going to link back to those clouds. This is going to be predominantly a cloud or hyperscale application area, and that's where it's going to continue to drive, but it'll have significant influence in HPC. Thanks very much.
And Sydney, a shout out for coordinating and doing all of this, because if it wasn't for you, we wouldn't be here today. So even though your banners didn't get here,
The content was rich.
the content was excellent, and I thank you guys as well. So thank you very much, and have safe travels if you're leaving this evening.
Whether you're down the road or further away. Thank you.